Okay, good morning, students. The previous class we discussed about the basic things of HVAC system and the human comfort zone and the psychometry of the HVAC system. Today we are going to discuss the vapor compression refrigeration cycle. The normally this is the vapor compression and vapor evaporation. The refrigeration cycle we are using normally we are using the vapor compression refrigeration cycle. This vapor compression refrigeration cycle having major four components, that is the condenser, expansion valve, and evaporator and refrigerant. These are the four major components we are going to use in vapor compression refrigeration cycle. The vapor compression refrigeration cycle is most common cycle based on which most HVAC device works. It consisting of four components which I already told: condenser, expansion valve, operation, and refrigeration. First, you should know how it will work. That's a major thing. In the ideal vapor compression refrigeration cycle, the refrigerant enter through the refrigerant will enter to the compressor as a saturated vapors and is compressed. Okay, and it is compressed here, and then compressed vapor will be cooled in condenser chamber, and at the time of cooling it will become the saturated liquid state, and then it will be expanded. It will be expanded from high pressure after condensation. First we are going to compress that one, and then we are going to condense that one in order to cool that refrigerant. In the condensation chamber, it will be converted into huge liquid. It will be converted into saturated liquid state, and it will be expanded from high pressure to low pressure in expansion valve, and then it will allow to the evaporation chamber. In the evaporation chamber, here we are going to get the cooling effect in the evaporation chamber. When that the condensed refrigerant, it will be in liquid state, that will be expanded from high pressure to low pressure in the expansion demand. It is a mixture. Once it will be expanded in the expansion valve, it is a mixture of refrigerant, liquid, and vapor comes out from the expansion valve. And where in this case it is a majority of liquid and evaporation of the liquid. It is when it will be expanded in expansion valve, the majority of that one will be in the liquid state, and it will be operated in evaporator chamber. Then evaporation of the liquid into evaporator gives the latent heat form. Okay, latent heat of evaporation, which is known as cooling effect. That cooling effect will be extracted for cooling purpose in air conditioning system. And then once again, after evaporation, once again the refrigeration will be recycled here, and then once again that refrigerant once again sent to the compressor chamber, and then the same refrigerant will be recycled in vapor compression cycle. Once again I will repeat, the refrigerant will enter to the compression chamber. That compressed refrigerant will be sent to the condenser in order to cooling purpose. At the time of cooling purpose, it will be in the condensation, it will converted into liquid state, and then it will be expanded to expansion valve to convert that high pressure to low pressure. So once it will expanded in expansion valve, the majority of it is liquid, and then it will be operated in the operation uh, chamber, and evaporate at the time of evaporation, it will give the latent heat of evaporation. That effect is known as cooling effect. It is a schematic diagram, and the refrigeration cycle and dynamic representation of pH and TS diagrams are shown in this diagram. This is the working of vapor compression refrigeration cycle. In the examination, they may ask, with a schematic diagram, explain the working of the vapor compression refrigeration cycle. At that time, you should write this diagram, and you should explain how the work of vapor compression refrigeration cycle is taking place. Now come to the next topic, that is the energy use indices. It is very need very essential to calculate the energy use indices in order to calculate the efficiency of the system. According to the AS/HRAE standards, the following are the current energy use indices for the refrigeration compressor, packaged unit, heat pumps, and chillers. The first we should calculate the coefficient of performance. The coefficient of performance is the ratio of refrigeration effect in kilowatt divided by the total power input in kilowatt. It will give the coefficient of performance. It is very important. These are the energy use indices you should calculate for refrigeration purpose to in order to calculate the efficiency of the refrigerating system. First, the coefficient of performance is the ratio of refrigeration cycle effect and the total power consumption in terms of kilowatt, and then we should calculate energy efficiency ratio. Energy efficiency ratio is the ratio of refrigeration effect BTU per hour. BTU is the unit of refrigeration effect, BTU per hour, and power input to the devices in terms of watts. And then we should calculate the kilowatt per ton. Then how much kilowatt of the power we are going to use with respect to ton indicates the electric power consumption of the refrigerating compressor per ton for refrigeration effect. It is a compression pressure in terms of ton. For creating that much of pressure in the compressor in terms of ton, how much power will be consumed, we should calculate here. That kilowatt per ton is equal to work input in kilowatt divided by refrigeration effect in terms of ton. And the fourth one, we should calculate integrated part of load value. So it is a combination of all the three effects. The coefficient of performance, sorry, it is a combination, combined effect of coefficient of performance and energy use, the energy efficiency ratio. That integrated part of load value, IPLV, is the single indices of merit that based on part load energy efficient ratio or coefficient of performance. It expresses parts load efficiency for refrigeration compressor, packaged unit, and heat pumps based on the weighted operation at various load capacities. So by using this formula, we are going to calculate the integrated part load value. That is integrated part load value is equal to 0.01 A plus 0.42 B plus 0.45 C plus 0.12 D, where A is coefficient of performance or energy efficiency ratio at 100% capacity, B is 75% capacity, C is 50% capacity, and D is 25% capacity. And let us move on to a very important topic. It is an impact of refrigerant on environment and global warming. You know the effect of refrigeration system, the HVAC system, to the environment and how it will affect the global warming. And you should remember what the refrigerant we are using is the chlorofluorocarbon. Normally we are using that one as an refrigerant. You know the our atmospheric layers, that is homosphere and heterosphere and stratosphere, like that. The the ozone layers, how this ozone layer will affect due to this refrigeration effect. These chlorofluorocarbon will release us some toxic gases that may cause us uh, that huge carbon dioxide will be released from this chlorofluorocarbons that may affect the damaging of the ozone layer. If the ozone layer is damaged, obviously there is an effect of ultraviolet rays enter into the earth surface. This may leads the different effect to the human beings or all the animals who are living in the earth. So these are some of the impacts of these refrigerants. So a lot of measure will be taken in order to avoid this refrigeration effect in the air conditioning or heating, ventilating, and air conditioning system. So a lot of research is going on in order to reduce these refrigerant effects to the environment. So for that reason, we are recycling this refrigerant. We are that the major thing is the recycling of these refrigerant is very important. So we are not allowing that leakage of the refrigeration effect to the atmosphere. We are recycling that for continuous usage. Thereby we can minimize the effect of the refrigerant to the environment. In instead of these chlorofluorocarbon, we can also use halogens or holo generated hydrocarbons that may have least effect compared to carbon fluorocarbons, but that is um, in a researching stage. So we are implementing that one to in order to overcome the refrigerant effect of the chlorofluorocarbon to the atmosphere. These may also cause this refrigeration effect is also cause the greenhouse emission. Anyhow, it is damage to the environment. So this may increases the temperature level of the earth. So the lot of precaution, lot of research is going on in order to avoid the effect of refrigerant on the environment and global warming. Now come to the very essential topic of this chapter is the energy saving measure of HVAC system. So how to do the energy audit is very important in HVAC system. Before doing the energy audit of an HVAC system, you should familiarize with what are the operations we are going to do in the HVAC system. If you familiarize the workflow of the HVAC system, then it is very easy to identify where we can take the necessary action in order to minimize the energy use, thereby energy conservation. So it is very essential in HVAC system to identify some of the things, so identifies the things which is going to used in HVAC system, and you should go through the you should familiarize the workflow of the HVAC system. To understand the workflow of the HVAC system, you should know the different operation taking place in HVAC system. So these are some of the hierarchy of HVAC system energy audit. First, we should check the HVAC system capacity of the building. So if it is sometimes what happens, if by observing the buildings we will install the HVAC system, but actually the capacity of the HVAC system is not required for that building. There other than also, in order to improper calculation, we are installing the bigger HVAC system that may lead the huge energy consumption. So that may cause a economy, that may increases the installation cost, the maintenance cost of the building. So you should first check the HVAC capacity of the buildings. At the time of checking, you should also observe what are the heating, ventilating, and air conditioning system which is naturally available to that building. You should also think about that. Next, you should reduce the internal loads. It is very important. But if you have to reduce the internal loads, if the unnecessary loads are there in the buildings, we can reduce those loads. And then improve insulation. The insulation is also very important. This insulation is not only for insulation is not means that in order to provide a protection from the short circuit. The insulation is nothing but this insulation will avoid the cooling of the room. It avoid the leakage of cooling of the room, and also it is also avoid the leakage of heating system of the room. Sometimes the from room would need the heating system. If there's a leakage of the heating system, so the huge heating system will be needed. If you avoid the leakage of the heating system by using insulation, so it is not necessary to increase the heating level. So you can also concentrate on the improvement of the insulation in the building. And next, you should have the solar shadings. It is very important. The solar shadings will increases the sometimes it will increases the temperature, otherwise it will decreases the temperature. According to our requirement, we are going to install these solar shadings in the building. And then you should usually inspect the plant and monitor the maintenance schedule. It is also very important. Sometimes improper maintenance is also lead uh, uh, it is also lead to the more energy consumption. So usually we have to inspect the plant and monitor the maintenance schedule, and they use the BMS, better management system, and then change set temperature. So it is very important. If we comfort with the women can comfort with the 20 to 26 degree Celsius room temperature. In if I want to maintain the room temperature at 20 degrees Celsius, the refrigeration coolants, huge coolant will be used for cooling purpose. So we can increase the temperature 20 to 25 degrees Celsius. So the cooling effect will be reduces, thereby energy will be conserved. So by just changing the set point of the temperature, we can also conserve the energy. Instead of 20 degrees Celsius, if you set with 25 degrees Celsius, obviously if it is a case of cooling system, if we can reduce the cooling effect, thereby energy consumption. If it is a case of heating system, uh, if it is a case of heating system, if instead of 25 degrees Celsius, if I set the heating system to 20 degrees Celsius in the cold countries especially, we can conserve the energy. We can reduce the 5 degrees Celsius. So the amount of heat, the power consumption to increase that 5 degrees Celsius of the temperature will be reduces, thereby we can conserve the energy. And then change of the filters is also very important. Sometimes we are using the filters in order to avoid the moisture content. Suppose the huge moisture content is there in the room, it will reduces the heating effect of the room because the most moisture will affect the absorb the heats. So the changing of the filters will also leads us move towards the better energy conservation. After all these observation, we can calculate the energy savings due to energy saving measures taken up. How? After observing all these things, we can decide which energy conservation methods we can adapt. Now we can discuss the energy conservation method one by one. Okay, there are many energy conservation system in energy HVAC system. I will just brief out one by one. First, you should uh, know what is that is can and van. It is very important. Sometimes they may the examination they may ask explain the difference between can and van. The can is nothing but constant air volume, and the van is nothing. VAV is nothing but variable air volume. The constant air volume means if it is a huge building, that refrigeration operation is taking place in top of the building, and using the ventilating duct, we are transmitting the air through the ventilating duct. Through that ventilating duct, we are transmitting the air to the different chambers, different cabin of the buildings. There, according to the requirement of that particular room, we can control the airflow to that room from the ventilating duct. Thereby, we can set our set point. Actually, this is the workflow taking place in buildings for HVAC system. But can is nothing but constant air volume. In constant air volume, the same constant volume of the air will be transmitted to the ventilating duct. The constant volume of the air will transmitted to the all the rooms through the ventilating duct. Suppose the air requirement of the room is lesser than the previous hour, then also it will transmit the same uh, volume of the air. Okay, suppose first morning 12 o'clock I need to set the temperature to 20 degrees Celsius. At that time, huge air will be needed. At evening 5 o'clock, I need a temperature 20 to 25 degrees Celsius. At that time, also it will send the same volume of the air to transmit the constant volume of the air constant volume of the air. So the power consumption to transmit the constant volume of the air will it increases the energy consumption of the refrigeration system. If it is a variable air volume, the based on the requirement of the temperature, the air volume which we required for the refrigeration purpose will be varied. So if I require 20 degrees Celsius, the based on 20 degrees Celsius, how much air is required, that will be transmitted to the ventilating duct. If it is a case of 25 degrees Celsius, how much air volume is required, that will be transmitted. So we are going to control the air volume in variable air volume system. So based on this energy consumption is goes on varies the based on the volume of the air. Thereby we can conserve the energy. So the variable air volume is having the better efficiency. It is better compared to the constant air volume. So this constant air volume with thermal reheat system, for that also we are going to use the thermal reheat system, and then which requires to the constant CAV with the thermal reheating system, which requires a circulate air to the cooled to meet the design thermal loads. If partial thermal loads conditions occur, reheat of a pre-cooled air is required. And then next one is the CAV system with the thermal reheat in the interior space and perimeter induction or fan coil. Here, for this system, the energy waste is reduced at the perimeter space, since a large portion of the air supplied to the perimeter space is recirculated within each space by either induction or fan coil units. By using fan coil units, we can going to control that air. And then all air induction system with the perimeter system. Here the induction units accept the varying amount of warm return air to mix with primary air for temperature control. The energy waste due to reheat is small for this system. However, extensive static pressure control is required at its thermals. And then come to the next one, the thermal CAV double duct system. So here we are going to use which have a cold air duct and hot air duct. It is a double duct system. Here we are going to use the two ducts, that is the ventilating ducts. One duct will contain hot air, one duct will contain cold air. By mixing that hot air and cold air, we are going to control the temperature. But the pressure of the volume of the air in the hot air duct and the cold air duct is the same. It is not varying, but by mixing that hot air and cold air, we are going to control the temperature of the cabin or a room where we required that refrigeration system. And next one is variable air volume. I already told that it is a varying air volume the based on requirement of the temperature. The first one is VAR system with the thermal read. We can read that air. the the air in the cabin, and then VAV system with the perimeter heating unit and VAV double duct system. Both it is also contain both two ducts and cold air and hot air, but there is a variable volume of the air in both the ducts. And this is the one of the energy conservation method, usage of constant air volume, controlling constant air volume and the variable air volume. And let us discuss one by one the different types of energy conservation methods in HVAC system. That first, second one is optimized ventilation air. That is energy required to condition ventilation air can be significant in both commercial buildings where it is used to provide the fresh air to occupant, and industry facility where it is used to control the level of dust, gaseous, fumes or vapors, especially in location with extreme weather conditions. So optimization of the ventilating air, what the we are going to optimize the ventilating air is required to in order to provide the comfortness to the people who are working in industries or in huge commercial buildings. So by optimizing this ventilation air, we can easily conserve the energy. Then use of variable speed drives, it is very important, the use of variable speed drives. So the many drives will be used in uh, refrigeration HVAC system for sucking up the air in air draft. Also we are going to use a machine or a motor. It will suck the air from the open atmosphere. uh, we'll call that one as a draft system. And then after refrigeration cycles, the space where we need to provide a cooling effect or heating effect, there also we are using some fans, means the motors at constant speed. Normally at constant, by setting the temperature, the speed of those motors will be varied in order to transmit the cooling effect or heating effect to the conditioning chamber. There we are going to use the drives. By using these variable drives, the variable speed drives, the based on the requirement of the temperature. Suppose if I set the temperature to 20 degrees Celsius, the airs required from the outer atmosphere will be huge. So that draft system will suck that air based on that temperature. If based on that set temperature, if you use these variable speed drives in constant air volume, the motor will run at constant speed. It will always suck the air, suck the same volume of the air all the time. But if you switch over from that constant motor drive, constant speed motor to variable speed drives, we can uh, change the speed of the motors or speed of the devices based on the set point of the temperature. And then replace existing chillers. That means the chillers will provide the cooling effect by heating effect to cooling. The chiller will convert that heating effect to cooling effect. By replacing these existing chillers to the modern chillers, we can also conserve the energy. And next, use of boost up system or alternative system. Some boost up systems we can use. Those boost up systems may be the use of a water side economizer, the boost up system. That means what the air we require by extracting uh, the leakage of flue gases, the heating effect, the extracting the leakage of the heating effect in the refrigeration cycle. We can extract that heat for economizing purpose. That means economizer means heating the water, heating the water in steam thermal power plant. We know that the working of the economizer. So the use of water side economizer in favorable weather condition, water can be cooled by using cooling tower instead of chillers. This cooled water will be circulated through the chillers. Circuits is heat exchanging coil. And then use decent cooling for industrial application. We can also use this refrigeration as an decent cooling in the industries. And then evaporative cooling can be used in a dry weather condition in series with chillers. It is uh, chillers. Okay, these are the some of the boost up system or alternative system we can adapt. And a huge HVAC system which will be used in the industries, we can extract these boost up system. We can use these boost up system for other operations in order to increase the efficiency of the refrigerating system. And then duct leakage repair. So we need to maintain the ducts, because through the ducts only we are transmitting the air. from one space to another space. If there's a leakages are there, that will lead uh, the losses. So the duct leakage repair is also very essential. Weekly once or weekly twice we need to uh, monitor the leakage in the ducts. And then heat recovery wheels, we can use these heat recovery wheels. What are the heat leakages is taking place, we can recover those heat using these heat recovery wheels. By recovering these heat, we can further provide the cooling effect in the refrigeration system. Thereby, if you use these heat recovery wheels, we can reduce the actual energy consumption to provide to generate that cooling effect or heating effect. That is an advantage of each heat recovery wheels. And then exhaust fan, it is also very essential. By using the extra exhaust fan, we can if we can transmit the hot air in the cabin to the outdoor surface. So next, reducing cooling loads, it is very essential. It is a manual work. It will be automatic work. I already told that instead of 20 degrees Celsius, we can switch over that one to 25 degrees Celsius, because the woman being comfortness temperature is 20 to 26.6 degrees Celsius. With it is that temperature is the comfort zone of the people. So by compromising the little bit temperature, we can better conserve the energy. We can get better conservation of the energy. And the next energy conservation method in HVAC system is operate the system at higher evaporator temperature and lower condenser temperature. It is very important. Higher evaporation temperature, you know the effect of the evaporation in vapor compression cycle, compression refrigeration cycle. I told that after expansion value, it is in the liquid state. In evaporation, we are going to evaporate that the liquid state of the refrigerant in order to get heating system. Thereby we are going to get the cooling effect. So if you increase the operation at higher temperature, so the heating effect what you are going to get in operation chamber will be huge. Thereby the cooling effect will be high. And then the lower condenser chamber, in the condenser we are going to uh, condense the compressed refrigerant. There we are going to get in the condenser, we are going to get after condensation, and it will be converted, that compressed refrigerant will be converted into the liquid state. If you condense these compressed refrigerant at a lower temperature, that the liquid formation of the refrigeration will be reduces. So that may also lead the better energy conservation. And next energy conservation method is improving the efficiency of air distribution system. It is very important. It is the top of the building, we are going to use this HVAC system, and through the ventilating duct we are transmitting the air to the cabin where we require that refrigerating or heating or ventilating or air conditioning system. So by this improving the efficiency of this distribution system means that transmitting the air through the duct with variable speed to the different cabins, we can conserve the energy. Thereby we can reduces the energy consumption to generate those effects. And then use of underflow air conditioning system, some diagrams are there in the textbook, you just go through that and then we will get an idea about these topics. Use of underflow air conditioning system, that is also one of the method. You just go through textbook, you will get an idea what is that use of underflow air conditioning systems. In underflow air distribution panel has less resistance than duct work, hence the fan power is reduced. And then relative warmer air is supplied to the room using this system, which improves the efficiency of the system. Okay, some of the with the diagram they explain this use of underflow air distribution system. We just go through the textbook, you will get an idea about that. And next thing is use of vapor absorption refrigeration system. I already told that in if I set that room temperature to 20-25 degrees Celsius. If it is that it's a case of cold countries, the outer temperature will be 4 degrees less than 0 degrees Celsius. The room temperature will be 20 or 20. If I set the room temperature 20 to 25 degrees Celsius, at that time I need a heating system, because the atmospheric temperature is less than 0 degree, but the room temperature is 20 degrees Celsius. I need to increase the uh, I need to use the heating system in that state. So at that time, that there is a possibility of vapor content in the cabin, the vapor content will absorb the heat. So if the vapor absorb the heat, that may reduces the temperature of the room. So if we so in order to overcome this disadvantage, we can use the vapor absorption refrigeration system. It will absorbs the vapors. It will absorb the vapors in the cabin, thereby the temperature of the room may be increases. And then replace vapor compressor based cooling with evaporating cooling. So instead of a compressed based cooling, we can use evaporative cooling. That is also one of the energy conservation. And then use of alternative refrigerant. Instead of chlorofluorocarbon, we can use the alternative refrigerator system. I told that the alternative uh, refrigeration systems are halons or halogen-generated hydrocarbons. Otherwise, this may reduces the ozone depletion due to the effect of fluorocarbon. So some of the stability of this alternative, the chlorofluorocarbon, normally instead of chlorofluorocarbon, now we come with a new thing, that is uh, instead of chlorofluorocarbon, we can use the HFC, that is heterofluorocarbon. We can use this instead of use just by replacing this refrigeration, we can get some of the stability in instead of HFC. Also we can use the CFC12, that is the new refrigerant will be uh, we are using now for refrigeration purpose. So these will avoid the ozone depletion potential, the global warming potential, the toxicity, flammability, the thermal and the chemical stability, COP, the coefficient of performance and energy efficient ratios, and availability and cost will be reduced if you switch over from these chlorofluorocarbon CFC to HFC or CFC to CFC12. And next, energy conservation method is that promote use of BMS and DDC. And next, thermal use of thermal energy storage based on AC system, and the use of variable refrigerant flow system. Okay, these are the different energy conservation strategy, energy conservation measures is used. We are not using all the things. The based on the workflow of that HVAC system in that particular plant, which one is suitable for us to uh, conserve the energy, which methods are suitable for that particular building or particular site or conserve the energy, we are going to use those one to conserve the energy. And the next topic is the encourage the green building concepts in India nowadays. Uh, in order to avoid the effect of the HVAC system to the global warming or to the environment, the government is initiating, the government is fixing standards, some standards at the time of construction of the building or construction of the shopping complex or construction of the industries. So some of the measuring points they have given at the time of construction itself that may benefit to the atmosphere. Some of for this reason the government is encouraging uh, the green buildings concept at present. So these green building concepts will reduction ready having some benefits. That one, those are the reduction in energy and water consumption, uh, the improved productivity due to maintained human comfort in the industries. So human comforts are there, the productivity is also increases. The rainwater harvesting. So these are the advantages of the concept of green building. Now, some of the design aspects of the green buildings are listed here. The 16 points they are given. That is the provision of charging points for electricity operated vehicle, promote employee to use mass transportation and shared vehicles. The more open space for ventilating purpose, the more open space should be there. The building orientation to maximize south and north exposure and maximize south and north exposure and minimize west and east exposure to flow the solar path. The planning windows and glazing on earth north well to minimize heat gain and maximize daylighting use of flow U value gauging. Normally you know that if you want to install the solar panel, the solar water heater in your house, always that the solar water heater, the glass will be exposed to south direction, because at the south direction the maximum solar heat energy will be extracted. The maximum solar energy will be extracted by that solar panels in solar water heater. For that reason, we are directing those solar panel in solar water heater to south space. So this are some of the basics we are going to use. We just go through this, we'll get an idea. And some of the use of rainwater harvesting and drop irrigations, and these are some of the measures will be taken. If you come to the HVAC system, the use of energy efficient chillers, cooling towers, VFD, VAN based, that is variable air volume based AHU, energy efficient motors, BMS, CFC free, and HVAC equipment, CO2 sensors. Okay, these are some of the uh, key points will be given by the government of India to at the time of construction of the green building. If you adopt these mechanisms in at the time of construction of the buildings, it will reduces the usage of the HVAC system. Usage of sorry, it will reduces the capacity of the HVAC system is needed for the building. Thereby, we can easily conserve the energy. This is also one of the energy conservation method, that is encouraging the green building concept in India. It is also considered as one of the energy conservation measure for HVAC system. Now come to the next topic, that is the star rating and labeling of BEE. Is the standard Indian standard is measurement BEE. Star rating of BEE for room air conditioning valid from 1st January 2012 to 1st December 2013. Now we are observing the stars in fridge. If you want to purchase a fridge, if you want to purchase the washing machines, there we are going to observe the stars. Those stars will indicate the energy conservation of those devices. If it is a 5-star washing machine, the same capacity 6 kg washing machine with 5 star, the same 6 kg washing machine with 6 star, the 5-star washing machine will consume the lesser power compared to that 3-star washing machine. So the starring system will be used. Last starting system will be is made essential for the selling of any selling of any equipments, electric, especially electrical equipments now. So those star will indicates the energy consumption of the device. The 5-star devices will consume the lower energy, and the lesser star will consume the higher energy. So this starring system will be made essential. Here we are going to observe 1 star. That's thereby they are going to give the energy usage of that storing system. Okay, these are the concepts we are going to get in HVAC systems, and I already sent some of the question paper to you people. The based on those questions, you should prepare the assignments. Okay, what are the questions they asked in those three the question papers related to this topic? You just prepare the just write the assignment for those questions. It will complete the HVAC system. Now the next topic is the energy auditing of the motors. In the next class, I will explain the energy auditing of the motors. Thank you.